So good day everyone. We are the group 7 and we will show you how to determine the specific gravity of a soil under ASTM D854.
So our main objective for today is to determine the specific gravity of a soil solids passing a sieve by means of a water picnometer as per ASTM D854.
So let's go.
The specific gravity of a material is the ratio of the mass of a unit volume of soil solids at the specific temperature to the mass of an equal volume of gas-free distilled water at the same temperature. The specific gravity of soil is usually reported at 20 degrees Celsius. It can inform us whether an object will sink or float in a reference substance dependent on its value.
In determining the specific gravity of a soil solids, we can be able to determine what type of soil is being tested. Furthermore, it helps in order to determine and figure out how much voids a soil contains and also understand how porous the soil is. By any means, it illustrates the ratio between the volume of the water to the volume of the voids. In determining the specific gravity of a soil solids, therefore, is an essential since it performs necessary calculations to be able to find whether a soil in a specific area could be able to withstand and support all the possible forces imposed on structures.
So, the first thing to do is to gather at least 15 kilograms of pure soil from a specific area. Our soil sample came from San Isidro, Coronadal City. The soil sample must be at least 1 meter below the ground. Air dry the soil sample before testing it to the laboratory. You can manually dry the sample by means of heating it into a pan.
In the laboratory, prepare all the materials needed to conduct the test. In determining the specific gravity, you'll be needing a sieve number 4, 4 pieces of picnometer, a thermometer, distilled water, weighing scale, and funnels.
Next, prepare the sieve number 4 and carefully put the dried soil sample. Cover with the lid and shake manually until only big particles remains in the upper part of the sieve.
Next step is to prepare the weighing scale and put the sieve over it. Press the 0 or tire button to disregard the weight of the sieve. Carefully put at least 250 grams of the sieve soil. Now, we will be dividing these 250 grams into 4 samples. This is why the next step is to weigh around 60 grams of the sieve soil and repeat until you achieve 4 of the samples. Now, these 60 grams at least will be the mass of the soil in G in the table.
The next step will be the determining of the weight of each picnometer. Each picnometer weighs differently, that is why we need to weigh each of them manually. Label each picnometer and list down the respective weights. This will be the mass of picnometer, G in our table.
After weighing the picnometers, carefully fill each picnometer with distilled water up to the indicator in the low meniscus. Utilize the funnels for easy transmission of water to the respective picnometers. Determine the temperature of each picnometer using the thermometer borrowed. List the data to your table carefully. This will be the temperature of water in degrees Celsius in our table.
After determining its temperature, weigh again the picnometer, but this time they are filled with the distilled water. Utilize the weighing scale of the measurement. This will be the mass of picnometer plus water, grams in our table.
Dispense all the water in the picnometer for the preparation of mixing the soil sample to the distilled water. Put the 60 grams soil sample in the picnometer carefully. Utilize a big funnel for easy transmissal of the soil to the picnometer. Then carefully add the distilled water just about to fill the spherical part of the picnometer. Shake the sample carefully until you see that the soil sample is mixed thoroughly to the distilled water. Then add the remaining water just about in the lower meniscus and shake again for the final mixing of the soil sample and distilled water. Repeat it to the other pycnometers until you have 4 samples.
After mixing, determine the weight of the pycnometer with the soil and the distilled water. Utilize the weighing scale for the weight measurement. This will be the mass of pycnometer plus soil plus water in grams in the table.
Determine also the temperature of each pycnometer together with each combination of soil and water. This will be the temperature of soil plus water in the table.
Put the water plus soil sample in the pan and heat it until it vaporizes. Wait until the water dissolves and only the soil sample will remain. Make sure that you will have a very dry consistency of soil before weighing it.
Weigh the soil sample together with its container utilizing the weighing scale. This will be the mass of dry soil plus container, grams in the table.
After confirming its weight, manually clean the container and weight it again in a weighing scale. This will be the mass of the container in grams in the table.
Lastly, we will get the mass of the dry soil by subtracting the data of the mass of dry soil plus container in grams from the mass of container also in grams. Now, this will be all necessary data to solve for our specific gravity.
And next, we have here the table for the calculation of the specific gravity of the solid soils. So as shown in the table, we have 4 number of samples that is being tested. First, we have the mass of the soil in grams, which is all about 60 grams. So as we can see, we have 60.2 grams for the sample number 1, while for the sample number 2, 3, and 4, we have 60 grams. Next, we have the mass of the pycnometer volumetric flask plus the water. So as we have weighed it earlier in this video, we have the following results, which are the 352.2 grams for the sample number 1, 348.2 grams for the sample number 2, and so on and so forth. Next, we have the mass of the pycnometer plus the soil and plus the water. So as we have already measured it by the use of the weighing scale, we have the following results, which are 389.1 grams for the sample number 1, 384.8 grams for sample number 2, and so on and so forth. Next, as we have cooked and oven dried the soil, we have the following masses of the dry soil, which are 56.3 grams for the sample number 1, 55.7 grams for the sample number 2, 54.8 grams for the sample number 3, and 57.9 grams for the sample number 4. Next, we have the mass of equal volume of water as the soil solids. So, it can be determined by adding first the mass of the pycnometer volumetric flask plus the water to the mass of the dry soil, and then subtract it by the mass of the pycnometer volumetric flask plus the soil and plus the water. So, for example, here, for the sample number 1, we have 352.2 grams, which to be added to the 56.3 grams, and then subtract it by 389.1 grams, which leads to the answer of 19.4 grams for the mass of equal volume of water. So, we have the same process of calculation for the sample number 2, 3, and 4 as what we did from the sample number 1. And now, we have the calculation for the specific gravity, which can be obtained by dividing the mass of the dry soil to the mass of the equal volume of soil. For example, for the sample number 1, what we need to do is to divide the 56.3 grams to the 19.4 grams in order to get the 2.90 specific gravity. So we have the same process for sample number 2, 3, and 4 as what we did from the sample number 1. And then, we should multiply the specific gravity to the given values of A at a specific temperature. So, as shown in the table, these are the values of A. So, as we measured the temperature of the samples number 1 and number 4, we got a temperature of 30 degrees Celsius. While for the samples number 2 and number 3, we got a temperature of 29 degrees Celsius. So we'll multiply the specific gravity of the samples number 1 and number 4 by 0.9974, while for the samples number 2 and number 3, we'll multiply the specific gravity by 0.9977. So we already have now our specific gravity at a given temperature. So 2.89 for the sample number 1, 2.91 for the sample number 2, 3.04 for the sample number 3, and 2.7 for the sample number 4. So finally, we will take the average of the 4 number of samples, which will result to 2.89 specific gravity of soil solids. So therefore, we can say that the type of the soil is clay and a silty clay.